Hello friends, today we are going to start the chapter that is solid state. Here we are discussing about all the important points regarding the solid state that is very important for the JEE and the advanced point of view. Here firstly we start from the unit cells and the crystal system. In this video we are discussing about the unit cells and crystal systems. Firstly we start from the unit cell, and before starting from the unit cell we discuss some of the points related to cube. That is what we have to remember. That is cube and a cube. That what are the points? Just I was spelling the points. That is important. That is, if we take the sides of it is a, then its face diagonal length will be root 2a, its body diagonal length will be root 3a, it having 8 corners, it having 12 edges, it having 12 edge centers, it having 4 diagonals, body diagonals, it having 6 faces, it having face diagonals, and it having 6 face centers also. So again I will spell that: it having 8 corners, 12 edges, 12 edge centers, 4 body diagonals, 6 face centers, 6 faces, and 1 body centers. This is the important information about the cube that we have to remember before starting the unit cell. As we come to the unit cell, then what is the unit cell? Unit cell is the smallest unit which repeat itself over again and again to form lattice. Okay, there was a two types of the unit cell. First of them was primitive and second of them are non-primitive. Primitive is also known as the simple cubic unit cell, and non-primitive are two types like BCC and FCC. That is body centered cubic cell, and FCC is face centered cubic cell. That's in the simple cubic cell there was this is the cube that we are expecting, in which in the corners all the atoms are present, in which all the corners there was an atom is present. And in the simple cubic, the Z effective of it is, Z effective is what? Z effective is nothing but the rank of it. What is rank? That is the effective number of atom present in the unit cell. Say effective number of atom, how much this atom contribute to this unit cell. That is, there was 8 atoms which is present at the corners, and the corners contributed to this unit cell, that is 1 by 8 parts only. So Z effective is 1. Okay, similarly let's move ahead to the another term that we have to remember here. It is the relation between R and A. A is the edge length of it, and R is the radius atom. So relation between them is 2a equal to R equals to A. Okay, this is the atom, it is the radius of between them, and this is the value that we require. Okay, this is what we require. Let's move ahead to BCC. In BCC, what is happening? There was a cube. In the BCC, not only at the corner atoms, only at the corners of the cube the atom is present, the atom is also present at the body center of it. So overall its effective, that is rank of it, was increases by 1. That is because this atom is completely present inside the unit cell. That's why it contributed full of its rank. Okay, so first term is Z effective, second is the relation between R and A, that is the side of the cubic cell, and third is the coordination number. Now, coordination number is the number of nearest atoms. as if we consider, so how many nearest atom it has? 1 2 3 4 5 6 7 8. So coordination number of 8 in this is 8. Similarly, if we have to know what is the coordination number coordination number of SC unit cells, that is simple cubic cell, that is if we consider the atom like this is the atom, so it is a unit cell, so it also there was a probability of finding an atom at this point. So number of atoms which is near to it is 1 2 3 4 5, and there was another just opposite to it, that is in this lane, that is here, that is 6. So coordination number of this is 6. Okay, similarly we move forward and know about what is FCC. In the FCC unit cell, there was also, firstly we draw the cube. In FCC, here the atoms not only present at the corners of the cube, but it also present at the face centers, that is center of the faces, that is centers of the faces, that is the centers of the faces. Okay, and so that it increases its z effective, that is 8 into 1 by 8 plus 6 into 1 by 2. This is because of the corners of the atom. This is because of the 6 phases of the cube having 6 atoms, and the face atoms will contributing half its part to the unit cell. So z effective is nothing but 4, and the relation between in the r and a is 2r, that is equals to 2a by I2. As you can see, there was an atom, but the we have to take this, we have to this is r, this is r, but we have to take this, and this is nothing but 2a by 2. Okay, this is the distance of the atom, and this is the relation between the radius of the atom and the distance between the interelectronic distances. Okay, the last point is coordination number. Its coordination number is 12. 4 because of the corners, 4 because of the face centers, and 4 because of the face centers of the another floor room. Okay, here we complete with the unit cells. Let's move towards the crystal system of the lattice of the cubic. Now we start crystal lattice system. Now let's start crystal lattice system. Here two parameters that we have to consider. First one is the distances between the unit cells atoms and the angles between the unit cell atoms. Let's take the distances be ABC and the angles between the atoms be alpha, beta, gamma, and how we can represent it on the coordinate axis, that is x, y, z. That is A is there, B is there, and C is there, and A making an alpha, this making an beta, and this making an gamma angle with the coordinate axis. Okay, now move to the another part, which is the important part, and that we have to remember about that crystal lattices and the distances between their atoms. Third, that is the angles that made between the atoms and the unit cell, that is the number of unit cell between them. Okay, the crystal lattice, there are different kind of crystal lattice. First of them is cubical, second of them is trigonal, third of them is tetrahedral, fourth of them is hexagonal, fifth of them is orthorhombic, sixth of them is monoclinic, seven of them is triclinic. Okay, now we move towards what is distances between them, that is A is equals to B equals to C. There is the distances between the atoms is equals. Here also a equals to b equals to c. Here a equals to b but not equals to c. Here a equals to b but not equals to c. Here a is not equals to b is not equals to c. Here also a is not equals to b not equals to c. Here are also same pattern will follow. So through the pattern we will easily able to learn it. Okay, and that is the thing that we have to learn. There is no shortcut for it. Alpha equals to beta equals to gamma, that is equals to 90 degree. That is alpha, we can just do it. That is alpha equals to beta equals to gamma not equals to 90 degree. Here again alpha equals to beta equals to gamma, that is equals to 90 degree. Here alpha equals to beta, that is equals to 90 degree, and gamma equals to 120 degree. Here alpha equals to beta equals to gamma, that is equals to 90 degree. Here again alpha equals to beta here alpha equals to gamma, that is equals to 90 degree, and beta is not equals to 90 degree, and here alpha is not equals to gamma is not equals to beta. Okay, the number of unit cells, there is a trick for learning the number of unit cells in each of the crystal lattice, that is 3 1 2 1 4 2 1. These are the things that we have to remember regarding the crystal lattice. And one of the important question which is asked in the crystal lattice, that is the crystal lattice having maximum number of Bravais lattice, that is nothing but orthorhombic. There was also another question which is asked from it, that total number of Bravais lattice in the cubical crystal system, that is 3 1 2 3 1 2 1 4 2 1. If we count the 3 4 5 6 7 7 8 9 10 10 14, 3 4 5 6 7 7 11 12 13 14, there's total 14 Bravais lattice which is present in the cubical lattice system.